In this lesson, we're going to talk about fission and fusion reactions. So first off, a fission reaction is defined by the splitting apart of the nucleus and release of energy. And this energy can be in the form of heat, or it can also be radiation. And to start a fission reaction, it can be caused when a neutron strikes the molecule, and then we have the subsequent splitting apart of the nucleus. And fission reactions are generally more complex than fusion reactions, and the atoms produced in a fission reaction are unstable and radioactive. And so because the products are unstable and radioactive, we can use fission reactions to produce energy to power our nuclear power plants. And also this energy can be used for nuclear weapons. And so fusion reactions, on the other hand, are just the opposite of fission. They are the combining of smaller nuclei into one larger one through the use of high pressure and temperature. And this actually hasn't been physically performed in our labs, but the products of a fusion reaction would be new elements that are more stable and non-radioactive, which is different than our fusion or our fission reactions. And fusion reactions are the process that power active stars. And so now we're going to go over a fission example to kind of show the process. And so if we start off with a uranium-235, we're going to have a neutron strike it, and this will initiate our fission reaction where we're going to break into smaller nuclei. And in this example, I'm going to show it breaking into Ba141 and Kr92. But it doesn't necessarily have to only break into two nuclei. It can break into more than that. And as you can see, the 141 and 92 does not total 236, which is the 235 plus the neutrons. So that's how we get 236. So in order to get equal masses here, we have to also produce 3 neutrons in this fission reaction. And so we can see that our products are smaller nuclei and neutrons, and then we have many different possible combinations for this. And so these neutrons that are produced in this first fission reaction can then go on to start subsequent fission reactions, and this would be called a chain reaction. So it can go ahead and bump into another uranium-235, and this is a chain reaction. And so this 235, we can show an example of a different combination of nuclei that it could be formed from this. And in this case, we can see Xe140 and Sr94. And again, this doesn't total 236. So in order to get 236, we're going to also need to produce 2 neutrons. And so this just shows that there are many different combinations for products of fission reactions. And if you had an instance where the products were less in their total mass than your starting mass, that would be called a mass defect, which is noted at the bottom. and the missing mass in the mass defect is changed into energy. And so this is how fission and fusion reactions are different.